So our two guest speakers today are Alex, who is the CTO at StorageOS, and Luis, who is an MTS engineer at Portworx. The format is Ask Me Anything, so I'm going to kick off with a couple of questions to you individually, and then you can respond in turn. And then Dom has a microphone, and she's going to run around and take audience questions. Also, if you tweet with the hashtag CloudNativeLung, then you can also ask questions that way. So we can kick off. So Alex, do you want to do an intro for yourself and how you got here, and then the same for Luis?
Sure. So my name's Alex Chircop. I'm one of the founders and the CTO of StorageOS. Is the mic working?
Is the mic on? Yeah. Can you speak up a bit?
My background is in infrastructure engineering. I've spent over 20 years now doing infrastructure engineering and operating systems and kernels and virtualization and networks and databases, that sort of thing. I spent 10 years at Nomura as the head of infrastructure engineering there, and spent 3 years at Goldman Sachs, where amongst other roles I was their global head of storage engineering. And after that, founded StorageOS. So that's me.
My name is Luis Pabón, and I started out with 12 years of experience at EMC, and then after that, 3 years of experience at NetApp, and then after that, the 3 years at Red Hat Storage. And so I've been a little more than 20 years in the storage field, from anything from writing block level to SSDs all the way to RESTful services. And just lately, before I worked a lot on I have an open source project it's called Heketi that I did for GlusterFS, and then I moved on to now I'm Portworx, and now I'm leading the open source development of Portworx, and also participating in the Kubernetes community on CSI.
Cool. You can keep the microphone. So, Alex, storage and stateful services seems to be one of the most difficult problems that people have with modern cloud-native systems. So most people here will have heard that you should avoid them entirely, just only build stateless services, but that isn't always practical. So can you give examples of where stateful services are needed and some gotchas that people don't think about when they're thinking about storage?
Sure. So I think when many people start looking at microservices and 12-factor applications and those sort of things, they often think of the application as being completely stateless, and that is a valid assumption for certain classes of application. But ultimately, no system is completely stateless, and state needs to be stored somewhere, whether it's an object store, a file system, a database, a key value store, or something of the sort. And then those systems need to run somewhere, whether it's in a public cloud, on-premise, or with some backing infrastructure. So what we find is that many applications and many systems have dependencies on there being some level of storage system or some level of storage environments that provides levels of state, but also some of the data services that we kind of expect to provide high availability for those applications, or perhaps security or encryption or other things like that. And more recently, with sort of DevOps environments, right, and the whole concepts of CI/CD, we have storage which is enabling things like snapshots and point-in-time copies of data, for example, to facilitate those sort of environments.
Luis, is there anything you want to add?
Yeah, that's a great question, and one of the things I've always thought about is that what's the comfort level of everybody using containers. And when it first started out is that when people were using Docker with containers, it was all about stateless, because the stateful question hasn't been answered yet. And actually, one of the things that happened is that Kubernetes started answering that question with his physical volumes and PVCs and that whole workflow. And that's actually then came on Docker with its volume API and Mesos also. So that whole world came after the usage of a stateless application. And because of that, once customers start using containers and start getting familiar with it and start getting used to it, and they say, okay, this is great, I can use my applications. Now I want to move the application that I'm using now, which are all stateful, into this world. And this is where we're starting to grow and mature. But I think this is something that's going to happen, and we're going to make it happen. And one of the things that I'm actually working on right now is, together in the community, is the CSI project, which is going to make it also possible to do this across a standard interface for all vendors.
So that's a good segue into CSI, because you were one of the implementers behind CSI for Kubernetes. Yeah. So CSI now is in alpha as of 1.9? It's
in beta now in 1.10.
Very cool.
In Kubernetes.
So maybe you can go into a little bit more detail about why does CSI exist and how does it affect all users, like Kubernetes users?
This is really cool because I actually, together with other team members in the community, proposed a talk on that and got denied. So,
this is your opportunity.
So now you're going to hear me say what I wanted to say there. So one of the things is that, like I just mentioned before, we got Docker Volume API, we got the Kubernetes in-tree API, we have the Mesos API. So we had all these different APIs, and it was very difficult for storage vendors to first get the experience and to do a correct driver for each, right? And at the same time, it was very difficult for them to deploy a driver for their storage on their own release cycle, separate from Kubernetes, because the driver was in the Kubernetes code, right? So then we needed a method that was standardized, that worked with every containerized orchestration system, what we call COs. And because of that, the community got together, which is kind of neat, and proposed this new API, which would standardize the model of how a client, one of them could be a CO, container orchestration system, can request storage from a storage system and then have it attached to a node and then provide storage to whatever, like a container or something. But it actually came out pretty well. Again, like I said, it was in 1.10 in Kubernetes support in beta now. Actually, I think it just got frozen like last week. The CSI specification, which is separate from Kubernetes, is its own community, that we just released 0.2 of that version.
And just to add to the importance of CSI, before CSI came along, there were a whole ton of different ways that you could do storage with different orchestrators. And we had a lot of different interfaces. So there was the Docker volume drivers or the DVDI interfaces, and we had native plugins in Kubernetes, and we had external storage providers and flex volumes, and different orchestrators were doing things in completely different ways, and different Kubernetes environments and different cloud providers were doing things in different ways. So the CSI spec is actually, it's not even Kubernetes specific, it's orchestrator agnostic, and orchestrators like Mesosphere are also adopting CSI, and in fact are very active in the community with that too. And what we have now is we have a storage vendor agnostic and a orchestrator agnostic way of interfacing the two environments.
I just want to add one more thing to it. There's sometimes some misunderstood usage of CSI. I just want to make very clear that CSI is not the answer to everything. It is a very specific API for attaching and creating storage. It's not, the goal of it is what I want to say is that it's not meant to be a management interface for your storage system. It is specifically meant to provision and attach storage. And that is, we're trying to specifically keep it very simple and very clean for our first version. And then later, Like, for example, I think there's a part of the community, too, working on adding snapshot to it. But that's something that may come in a little while. So.
Great answer. I'm going to pause here and open up to audience questions. So anyone have a question at this moment? Dom, you can pick.
Does cloud native automatically imply distributed? And if so, how do you mitigate against the enemy of distributed state, network partition?
So that's a very good question. And no, I don't think cloud native inherently means distributed, although that's where most people go down. There's a lot of an argument, we have endless debates in the community as to what cloud native storage actually means, and it's not an easy topic to nail. We've tried to put some principles down on paper at StorageOS, for example, where we've kind of said cloud native storage needs to be composable and declarative, and it's got to be agile, and it's got to have an API, and really in these sort of environments, it's also preferably deployed as a container and managed by the orchestrator too. But that doesn't necessarily imply it's going to be fully distributed or fully sharded or anything like that. You can have different systems for different models, and distributed systems work for some environments, and they're particularly great for things like object stores, and more deterministic systems may be more applicable for volumes that you're provisioning to a database, for example.
I don't know if that answered your question about the network partition. Don't know if you guys want to say anything more?
Nothing. I think you did.
Okay.
I just wanted to add one key thing, which you mentioned on, is I don't think there's an enemy here. And also, I don't know we can really define, we're still looking for the exact definition of what cloud native means. So we're still in the process of, once we define that, then we can say this is what it means, this is what it doesn't mean. So that we can then decide how is it that we can answer the questions you have. So.
Go for it.
Hey, what do you think were the main reasons why Docker storage plugin failed? Why nobody actually adopted it?
The volume plugin?
Yeah.
I don't think it's failed. I think that I think it's actually pretty cool. It has to use a RESTful service to communicate to a driver. But I think it has to do with the success of Kubernetes, right? It's not really that Docker failed. I think the success of Kubernetes has really taken off. So that's just my opinion.
So why does Kubernetes not using it?
Kubernetes has its own model of defining the request. And, oh, you're talking about how Kubernetes doesn't use the Docker volume API?
Well, that native plugin that you compile your plugin into the storage plugin for Docker.
That's a question for the SIG storage team, but I can just guess that the interface and at the time, all the plugins were in the tree. So there was no need to have an extension. And that's where the flex volumes then came after, and then CSI. So it's not like they said, no, we're not going to do that. They just never came to a reason why they needed it. So.
Do you want to go over here? We'll take 2 questions here and then do a couple more.
Thanks.
And then we'll come back to audience questions. Yeah.
For StorageOS on your website, I think you say that you're a multiplier less expensive than Amazon, than AWS. And so I'm wondering if there are circumstances where you would recommend your client use AWS instead of StorageOS, or if it's like for like and just less expensive.
Damn those marketing gremlins. So It's not a case of whether you'd use StorageOS or EBS. StorageOS would be providing data services for providing, say, replication across availability zones, or providing, say, inline encryption using keys that only your application knows, rather than having to provide your keys to Amazon to do encrypted EBS volumes, for example. So it's not an either or. It's a case of providing ways to provide that higher availability, reducing the attach and detach times for EBS volumes, providing that availability across, say, availability zones, and things like encryption and integration into Kubernetes would be the use case there.
Cool. Run, Dom, run.
So I note when you were saying about CSI, you were saying it's at the node level. Yes. Why at the node level rather than closer to the container level, where most people tend to make use of the storage? Yeah, good question. One of the reasons for that, sorry to potentially have a go at StorageOS, is that I have experienced issues where an EBS volume, as an example, has taken a long time to move from node to node.
Okay, that's two questions, but I'll ask them both. All right, so the first one is, why is CSI at the node level? And the reason is because containers are not VMs. And the reason is that the attachment and detachment and everything that happens to storage is actually at the host. The host kernel is the one that has to do all the I/O. So you must communicate with the host kernel, and to do that, you need to attach it to the node. Now, if we were talking about VMs, then we could just do like a QEMU attachment to a KVM, for example, and then you can not attach it to the host. But containers all talk to the kernel, and the kernel is the one that rules the world, right? So the second question was?
It was more or less along the lines of, for the storage, you're typically wanting to utilize it at the container level.
Oh, the EBS one.
Rather than at the node level.
So the question on EBS is sometimes taking a long time to detach and attach, right?
Yeah.
So
the reason is because as the container moves from node to node.
That's right.
Yeah.
Okay, cool. So that is a great question, and I'm glad you bring it up. And it felt like it was a setup question, but it's not. No, because this is really, really cool. That I like that question because EBS and, again, some storage systems, when you design a storage system, you design it for a specific use case, and you design it to be successful as you can for that use case. And EBS was designed to provide storage to VMs, and not designed to attach, detach as fast as a container moves, right? And what happens is when we provide the use case of containers moving from node to node, and not only that, that's across one zone. But what happens when the container moves from that zone to another zone, and then you're just pending forever, right? So you have to design storage systems for the environment that you're going to use them for. So you have to design them for the containerized world, right? And you have to design understanding how the container orchestration system behaves. And and that's why you have to know that if you're across zones or you are across regions for maybe in the future, that you have to design a storage system that's able to handle those type of use cases. Does that answer your question? Okay.
Great. Okay. So I'm going to ask a question to you, Alex, now. Okay. So Rook and Vitess were both recently accepted as CNCF Inception projects. So what are they? Can you give an overview? And then how do they compare to something like StorageOS or to Portworx?
Sure. So it's probably worth pointing out that breaking news today, the CNCF has reclassified Inception projects to be sandbox projects, and inception projects are CNCF as a foundation, the Cloud Native Compute Foundation, is there to help sponsor and foster different projects and help build their communities. And they now have 3 levels. They have this sandbox level, which is an intro level where you have sort of some of the earliest projects which may not have a huge community base or a huge contributor base, but they're interesting to the CNCF and they're interesting to the cloud native story. And then we move up to incubation projects where the projects are under more intense sponsorship, and they have marketing sponsorship and other funds available to help them with documentation and other things like that. And then finally, you have the graduation level, which is where Kubernetes is just being graduated now this week too. So what the CNCF was looking for was a number of different projects which allow the community to start experimenting with some of the different open source storage systems. And cloud native storage doesn't, as we said, it's kind of a vague term at the moment. It's not very tightly defined and can mean lots of different things. So, for example, in the case of Rook, Rook is an operator, and for those unfamiliar with Kubernetes operators, it's effectively a method to help you install and manage Ceph environments within Kubernetes. Vitess, on the other hand, is probably a more it's a much more mature product, and it is primarily sponsored by YouTube and Google, although it's got quite a wide community support, and it's a way of sharding MySQL databases, and it's the primary database behind the YouTube engine. So at YouTube, they have about 10,000 instances of Vitess driving the backend metadata for all the video systems. And Vitess is also seen as another type of cloud native storage.
Mm-hmm. Do you have anything you want to add?
No, I think that was a very good description of both projects, and one of the things that we wanted to add to that is that CNCF is looking at the Apache as an example of having inception projects. So Apache has done a good job, and we're actually learning from that. So I also participate in the CNCF at TOC. So.
Okay, so we've kind of talked about what Rook and Vitess are, but how do they compare with what we're calling cloud native storage or container native storage, like the products that you actually work on? How are they different?
So as we discussed, Vitess is a database. So it's kind of like a front end proxy for proxy is probably a simplification, but it sits in front of a variety of MySQL instances and helps you shard and join queries across a number of different databases. And Rook is it's an operator that helps you install Ceph, whereas StorageOS and Portworx are actual storage systems in their own right. So they're not just an interface or a method in between other systems. They are the actual storage system. They are software-defined storage systems that are deployed as containers and help you do both scale-up and scale-out storage within a Kubernetes or an orchestrated environment.
Yeah, exactly right. And I know that the Rook project is also looking forward to orchestrating other storage systems other than Ceph. But right now, their main goal is Ceph to install that. So.
Cool. I'm going to turn it back to audience questions. So anybody have questions? There's one here.
Yeah, I think it was the guy from Portworx said a little earlier that CSI was great at the attach, but stopped short at managing it.
Yeah.
Can you go into some detail on that, please?
Sure. You want to know the reasons why that decision was made and things like that?
Yeah.
Yeah, that's a great question. Storage management is actually quite difficult, and trying to make it standardized across all storage systems. That each one has their own ways of doing things. And the key thing that the container orchestration systems were looking for that use case was the ability to create volumes, delete them, and attach volumes. So that's, in other words, CSI was trying to answer the questions that container orchestrations had, which is a solution for managing, or being able to create volumes, or provision them, and attach them, and that was it. So, and also at the same time, to tell you the truth, it's quite difficult to get an agreement across all storage vendors at the same time to an interface. So we just wanted to keep it as simple as possible with as few APIs as possible as a first step. It's a little, it's a baby step. And then after that, we can see the success of that, and we can then grow that and mature it. But I think for now, it's all about keeping things simple and keeping things reliable.
There's a question over here.
Hello, I'm hoping to still maybe 2 questions, but just out of interest, I wanted to know about the sort of file locking. So if the data is being shared between 2 containers, and let's say, like the writes and saves, etc., to the file, is that locking and that resource management handled by StorageOS?
So in Kubernetes, you have 2 concepts when you're trying to request a persistent volume. You have what they call a write once, which is effectively a volume that's only used by 1 container, or you have a write many, where the volume can be used by multiple containers. If the volume is going to be used by multiple containers, it is effectively a shared file system at that point. And if you're going to be using that sort of functionality, then the file locking is going to have to be done at the application level in a sort of traditional POSIX kind of way. There's no magic to kind of get away from that.
No, that's exactly right. Before, when I worked in Red Hat Storage, that question came up a lot. We're using GlusterFS, but yeah, we would say exactly the same thing. It's all about just using normal POSIX semantics, file lock, exclusive lock, and then you'll lock out the other application if you're working on the same file. So.
All right, cool. And just one more quick one. When asked about the sort of AWS and the multi-cloud side of things, you sort of mentioned encryption as a key feature. I was wondering, I've heard before in the past in regards to an encryption, TrueCrypt, and how it can sort of encrypt data at runtime, basically, or dynamically. Is that the feature that's offered in StorageOS, and like sort of encrypts everything before writing to disk? Yeah,
correct. So the encryption feature is an inline feature. So the StorageOS data plane encrypts data using a key that's only known to the application, and that is effectively a whole disk at a block level encryption. So I guess similar to what TrueCrypt used to be able to do, yeah.
Oh, you wanted to add?
Yeah, no, it's fine.
Just one more question around encryption. What actually are overheads of like maintaining the encryption on OS level? Because like when we're talking about any cloud providers, they actually use RISC processors or HSM devices to kind of leverage of performance of encryption. How you actually kind of handling performance degradation and IOPS degradation when you're encrypting those data?
So that's a very good question. So over the years, in the past, when encryption used to have to be done at sort of line speeds, there used to have to be offload engines. However, nowadays, Intel processors have a bunch of accelerated AES functions built in, and they primarily built them in to support things like SSL and TLS connections. But ultimately, the same instructions provide wire speed and low latency encryption. So, for example, a 4-core Intel processor could probably do about between 5 and 8 gigabytes per second of 256-bit encryption. So in reality, most of the time, it's not encryption that's the bottleneck, or the CPU that's the bottleneck.
So basically, you're just relying on risk algorithms that are embedded into processes, like whatever AES encryption or other algorithms available by processor. You utilize just them and not something like software-defined.
No, well, okay, that's a complicated question. There are libraries that you use for encryption, and those libraries take a decision if they're going to do that all completely in software, or they look at the CPU to determine if the CPU can handle it or offload it, and then they would use those CPU opcodes. And those CPU opcodes normally are just a few clock cycles on the CPU, so they are very highly optimized. I don't know if you know, but the Golang language, when it does map, I want to make sure, please let me know if I'm incorrect to this. I could be incorrect. But when it does the map hashing, it checks to make sure if there's an accelerated CPU to be able to do the hashing much faster. So.
Any other questions?
Okay, this might be a bit of a silly question, but why use block storage at all in cloud native? As in, is that the underlying backing storage for your database service or your managed database?
Because it's awesome. I don't know. What else is that? No, that's a good question. I'm going to let him answer first, and I'll ask.
Oh, thanks for that. No, but you're right, it is awesome. No, so you know how we said at the end of the day, no application is stateless, and they're going to be storing state somewhere. And even if you're storing state in a database or an object store or a key value store, ultimately they're going to need to store something somewhere. And at the end of the day, the lowest common denominator is going to be a file system on a block store somewhere. And that file system and that block store can be based on a distributed system, or it can be based on something like StorageOS or Portworx that's going to be providing that block service across an infrastructure provider. Because what we find is many organizations are actually building out their own object stores or their own specific databases, and they need block store and file systems as that backing store.
Yeah. And actually, file systems are hard. Okay, and block storage, you can add a lot of features, and you can use very well-supported, for example, like XFS, ext4 file systems that have been around for a long time. And those file systems can then use the block storage with all the features that you can put in, which are much easier to add to block storage. It's predictable, it's block-based, you can move it around, you can dedupe it, you can do a lot of things. But when you have to deal with inodes and POSIX, it becomes extremely difficult, especially for a distributed system. So that's why it's much easier for systems to provide a very good, reliable block storage than it is to provide a very good, reliable distributed file system. I'm not saying it's impossible, but it's definitely harder.
and that is why it took so long for things like Gluster or CFFS, for example, to get to the level of maturity. Yeah. To took the better part of 7 years for CFFS to get a production quality label, for example.
Okay, thank you. So in theory, if my strategy is to consume managed service database for greenfield new deployment, I could get away with not needing block storage.
What, could you say that again?
So if my plan or my architecture, my strategy is to consume managed services for databases,
yeah,
either NoSQL or SQL, then there's no requirement for me potentially to have block storage.
But the file system, the database will be running on something, maybe a file system, and that file system is running on block. So the end is going to block. So.
Yeah. So I mean, I don't trust myself to write a database as great as Cloud Spanner on my own block storage. So that's kind of what.
So I'm just trying to understand the question. You're saying that you could write the database straight raw on the block?
Well,
just use RDS. Just use database as a service?
Yes.
Okay. That goes back into some people can do that, some customers can do that in some use cases where they can use a stateless application by having the state kept as a service. But those services, in the end, are writing to block storage. So if you wanted to provide that as a service, maybe your company wanted to provide a database as a service like Vitesse, for example. In the end, that Vitesse library is running to block store in the end. So
Thank you.
yeah.
I think there was a little bit of murmuring there when RDS was mentioned, and I'm sure for a lot of people they're like, managed services, managed databases, but why? What's the benefits or the trade-offs?
I'm just going to mostly echo Lewis here. So it is going to be down to the use cases, and that could be, there could be technical drivers for that, and there could well be commercial drivers for that. So many of the businesses that we're talking to have cloud instances, but they also have on-premise instances, and they want to have a same look and feel and the same way of orchestrating and composing their applications for both the cloud and on-premise. In which case, they might also have a rich heritage of running specific database versions for specific reasons, and they want to run their own database as a service. Additionally, there could be commercial reasons. So RDS might be good for a certain size of system, and then you get to the point where you're paying so much for the additional replicas, and you're paying that premium to the cloud provider to provide your databases. That at some point you say, actually, maybe one instance is fine, 2 instances is okay, but if I have 10, 20 RDS instances, perhaps it's time it's more economical to run your own database as a service on storage specialized nodes in your cloud provider, for example, and you can get better performance and maybe better availability.
So I think we have time for one more question. No? Okay, in that case, I'm going to pose my own question to you guys. So you guys are really tuned into what the storage SIGs are looking at next. So if you were to give a prediction for what's going to happen in the next year for storage, for cloud-native storage particularly, what would you say? So in one of the keynotes at KubeCon last year, Alexis Richardson actually said, he's the chair of the talk, and he said, cloud-native 2018 is the year of cloud-native storage, and I think what we're seeing is that as different organizations and different communities go through their maturity cycles, and they get to a point where they've moved some of the stateless stuff and they've moved some of the easy stuff, and they've got a ton of stateful stuff that's sitting on legacy systems, whether it's sort of operator managed or old hardware or on-premise versus cloud and those sort of things. And what we're seeing now is the maturity level and in a lot of these organizations takes them to the point where they're now looking at moving those stateful applications into their new cloud-native environments. And I'd say 2018 is the year for cloud-native storage.
Absolutely. I think that, just following what you were saying, I think the biggest change for 2018 is going to be the users. I think it's going to be the users. I mean, we've been working on storage for a while, so we've been, to us, it's just this, we knew it was important. We know storage is important. We know stateful applications are important, but it is going to come down to the users. It's going to come down to the experience of once the user starts saying that stateless applications does not provide maybe enough for them, for their use cases, or maybe they do. Then when they make that decision to go to stateful applications, what do I do now? And then once they bring those use cases specifically to the communities, the Kubernetes community, the Mesos, the Docker communities, and on the storage sections, and they start bringing up the use cases like, this doesn't work for me. That's the interaction we're looking for. The community itself in Kubernetes specifically, where I participate, is looking forward not just to storage developers to participate, but the users. And we're missing a lot of them. And so please participate. We look forward to your participation there. We look forward to use cases there, so we can add more innovation into our container orchestration systems.
Great, good stuff. So we are out of time, but Alex, Luis, thank you very much for your time. Is it okay if people contact you later if they have further questions?
Absolutely.
Yeah,
Yeah,
you'll be hanging around. So I guess Twitter or whatever.
Yeah, and I'm also on Kubernetes.slack.com as LPABON. So, yeah.
Cool. So thank you very much. Big round of applause, please.